This video will teach you how to calculate the molar mass. When we talk about the molar mass, that just means the mass in grams of 1 mole of any substance. So first what we're going to look at is how to calculate the molar mass of a single element. So when you're just looking for the molar mass of a single element, it's very easy. You're actually going to use the average atomic mass of that element from the periodic table. So remember, the atomic mass is that number that's underneath the symbol and the name for the element, and it's the number that has the decimal point in it. That's your atomic mass. So for example, if you're trying to find out how many carbon atoms are in 1 mole of carbon, you'll just find carbon on your periodic table, and then you'll use the number that they give as the average atomic mass, and that'll also be your molar mass. Usually when we give the molar mass, we go ahead and round to 3 numbers after the decimal point. So from this periodic table, it actually has 4 numbers at the end, but we'll just round it to 12.00011 grams. Go ahead and use your periodic table and check and see if you can figure out how many grams of magnesium are in 1 mole of magnesium, and how many grams of copper are in 1 mole of copper. I'll give you a hint. Magnesium is here in the alkaline earth metals, and copper is here in the transition metals. Your numbers that you find for the average atomic mass should match the ones here given on the screen. And that average atomic mass that you find for each element is also equal to the molar mass, or the mass in grams of 1 mole of that element. Okay, let's do a quick check to make sure you get it. So looking at a couple more examples, if we want to find the molar mass of 1 mole of bromine atoms, then what we're going to do is look on the periodic table and find the average atomic mass, which from this example is showing 79.90, and we'll say that that's also the molar mass, and we always put the unit grams per mole. That's the unit we use to express molar mass. So we'd say that in 1 mole of bromine atoms, that's equal to 79.90 grams per mole. Another one, if we look at tin, that's SN. Again, you're going to use that number underneath the average atomic mass, and that will also count as your molar mass. So we'd say that for tin, the molar mass is 118.71 grams per mole. Alright, so now we know how to calculate the molar mass of a single element. We also sometimes need to calculate the molar mass of molecules and compounds. So those are substances where there's more than one element present. When you're looking for the molar mass of a compound or a molecule, it's the mass in grams of 1 mole equal numerically to the sum of all the atomic masses of each element that's in that compound. So for example, if we take a look at 1 mole of calcium chloride, CaCl2, then what you're going to do to calculate the molar mass of that compound is you'll find the mass of each of the elements that are in that compound. So in calcium chloride we have calcium, and from our periodic table we'll find the mass of the calcium. And you can just write that down. Then we also have chlorine. So from the periodic table we can find the mass of the chlorine. Next step you have to do when it's a compound is you have to make sure that you multiply that mass by however many of that element there are in the compound. So if you look at calcium chloride, there's only 1 calcium in that compound. So you're going to multiply your mass of calcium by 1. If you look at the chlorine part, there's 2 chlorines. You can tell that by the little subscript 2 in that compound. So you're going to multiply the mass you found for chlorine by 2. Once you multiply that by 2, you're going to go ahead and add it all together. So if you add up, this one we got 40.078, and then we're going to add that with our mass of chlorine times 2, which will be 70.906. When you add those two things together, you should get 110.984. And again, we use that unit grams per mole. So that would be the sum of the masses of all of the elements that are in that compound. And that's how you find the molar mass of a compound or molecule. Alright, you've probably got the hang of it by now, but let's go ahead and do two more examples just to make sure that you understand how to find the molar mass of a compound or molecule. So let's start with this potassium oxide. So in potassium oxide, you have two elements. You have K potassium and O oxygen. So what I want to do first is look up the masses of each of those elements on the periodic table. Looking at the periodic table, I can get the mass for potassium, and I can get the mass for oxygen. Alright, now our next step is to multiply those masses by however many of that element are in the compound. So for K, we have 2. You can tell by the little subscript 2. For O, we have 1, because there's only 1 there. Okay, whenever we put this in the calculator, this will be 78. Oops. Sorry about that. 78.196. And then this, of course, just times 1 will stay 15.999. Okay, last step is to add those together. So when you add those together, final answer should be 94.195, and the unit we always use is grams per mole. So you can just write it grams over mole. Okay, and that'd be your answer there. All right, let's try one more together. So in this compound, this is aluminum hydroxide, and you actually have 3 elements. So you have aluminum, you have oxygen, and you have hydrogen. So from the periodic table, I'm just going to get the masses of each one. You can check your periodic table also and see where I'm getting these numbers. Okay, so I have the masses for aluminum, oxygen, and hydrogen. Now I'm going to multiply them. So there's only 1 aluminum. There's 3 oxygens, because remember that little subscript 3 outside the parentheses means that the 3 goes to the oxygen and also to the hydrogen. So I'm going to go ahead and multiply the hydrogen by 3 also. Okay, do a little bit of math. This is going to stay the same. Okay. And all I'm doing is plugging these into the calculator. If you can do really good mental math, you can do it that way. But I can't. Okay, so when I add all those up, I get 78.003. So that's going to be my molar mass for the aluminum hydroxide. And again, our unit is always grams per mole. So that's your answer. All right, hope you understand how to find the molar mass of both a single element and a compound or molecule.